Hey everybody. So this week's topic is molarity. Now we're continuing our unit on solutions by talking about the concentration of solutions. Now we can see with a colored solution, like iced tea, for example, how concentrated something is based on its color. The darker the color, the higher the concentration would be. But it turns out that we can actually measure the concentration numerically using an idea called molarity. Now, up at the top of the screen, you see that molarity is defined as the number of moles of solute per liter of solution. So, a 3 molar solution of salt, for example, would contain 3 moles of salt in 1 liter of solution. And if we change the volume of that solution, the amount of moles that we would need to add would change accordingly. Now, right in the middle of the screen here, I'm going to go ahead and put a star around this. We have the equation that we're going to use to calculate molarity. Now, we're going to bring in a little bit of math this week, but we're going to try to simplify it as much as possible for you to make your job easier. Basically, if you know any two of these things, you can always solve for the third. And in the next part of this video, we're going to talk about how we go about that. A couple things that you're going to want to keep in mind when you're navigating this equation. Sometimes you're going to be given an amount of a substance in grams. For example, instead of saying 3 moles of salt, I might tell you that we have 50 grams of salt. In that case, the good thing that we've already learned this year is that you can convert between grams and moles by knowing the molar mass of a substance. Probably in a lot of cases, we're going to give you the molar mass to allow you to carry out that calculation pretty easily. But if you're not given the molar mass, you would simply calculate that molar mass from the periodic table, and you would divide by that molar mass to get moles. And that's the number that would go into your equation. Now, also, occasionally, it makes more sense for us to measure the volume in milliliters. In that case, just remember the simple conversion that we've done for really the entire year, where 1 liter is equal to 1,000 milliliters. So I've put an example down here at the bottom that would allow us to kind of remember how to solve one of these equations. Now, in this case, if we're trying to go from milliliters to liters, we're going to move that decimal point, which right now is at the end of the number. We're going to move it 3 places to the left because there are 3 zeros in 1,000. So we would just go 1, 2, 3, and 250 milliliters would become sorry for the technical difficulties here, would become 0.250 liters. I think most of you can probably do that in your head. I'm not going to ask you to do the work on that, but that's how you would convert that if you needed to. In this equation, you always have to have moles on the top. You always have to have liters on the bottom. So just make sure if you need to convert that you do so. So I'm going to move on to our second page here. And up top, I put kind of a simplified version of the molarity equation that I introduced on the previous slide. And what we're going to do here is just solve for the other 2 quantities. If you're asked to find the molarity, all you got to do is take the moles, divide by the number of liters, and you've got it. If you want to solve for moles, you need to manipulate the equation a little bit. So I'm just going to go ahead and do that here. So molarity is equal to moles divided by liters. Now, in order to do this, we're going to need to get moles by itself. So we're going to multiply by liters on both sides. Sorry, I ran out of room there. And we're going to end up with liters times molarity is equal to moles. So if you're ever asked to find the number of moles that it takes to make a certain number of liters of a solution with a certain molarity, all you would have to do is to take the number of liters and multiply by the molarity, and you'll get the number of moles. So when you're solving for liters, it's going to be slightly trickier. There's going to be one more step involved, but still nothing we can't handle. We've seen a lot of these simple equations throughout the course of the year. So again, going to start with our base equation. And the goal always is to get the quantity we're interested in by itself on one side of the equation. Now, right now, it's in the denominator, so we're dividing by liters, essentially, so we're going to need to multiply by liters. I'm going to do that right here, and I think I should have just enough room to do what I need to do. So liters times molarity gives us moles, just like before. Now, in this case, we're going to need to divide both sides by molarity to get liters. So, the number of liters that we can make from a certain number of moles, if we want a certain molarity, is going to be the number of moles of that solute divided by the molarity of the solution that we're looking for. So with that, you should be able to solve for any of these quantities as long as you know the other two. So hopefully that'll help you get a head start on this week's calculations. And if you have any questions, as always, you know where to find me. Thanks.